Let's review series and parallel circuit rules. We have on the left a series circuit. We have on the right a parallel circuit. In a series circuit, the resistors are in a one after the other fashion, and the equivalent resistance is found by summing the resistors. In a parallel circuit, the resistors are in a parallel sort of combination, and the equivalent resistance of that portion of the circuit is found using what I call the 1 over relation. In a series circuit, there is only one path for charge flow. So if you know the current in any portion of the circuit, you know the current, that is the amperage, in any other part of the circuit. In a parallel circuit, the current will split when it meets a junction. So if I have 3 arrow tails down here, then I have 3 arrow tails through the battery. You can think of it as 3 amps if you want. 3 arrow tails. When I get to this junction right here, some of the arrow tails will go through resistor 1. The rest will go through resistor 2. Let's say 1 through resistor 1 and 2 go through resistor 2. These are the rules we need to keep in mind when we're doing what comes next, combination circuits. So let's try solving these problems. Now, you might feel like this child up here, because if you look at this schematic diagram, you can see that we have parallel elements, but then those parallel elements are in series with resistor number 3. So we have to use the right rule at the right time. We're given that this is a 24 volt battery, and we're given the resistances for the resistors. So first, let's pretend that we were to take out that part of the circuit that I've colored in blue here and replace it with just a single resistor. In other words, let's tear out these two and put one in its place such that the battery would be none the wiser. And we can see that those two resistors are in parallel. So to find the equivalent resistance of this portion of the circuit, we would want to go 1 over 8 plus 1 over 8, add those up and take the reciprocal. That's 4 ohms. In other words, if we tore this portion of the circuit out and replaced it with just a single resistor, we should replace it with a 4 ohm resistor, and the battery wouldn't know that we had done anything. That 4 ohm resistor, that make-believe 4 ohm resistor, is in series with resistor number 3. Resistor number 3 has a resistance of 4 ohms, so the battery perceives that there's only one resistor, and it's an 8 ohm resistor. As far as the battery's concerned, there's just one resistor and it's 8 ohms. Ohm's law has to hold for any row in this table, so clearly there must be 3 amps going through the battery. Well, if we look at this circuit, we can also see that there must have been 3 amps that are going through resistor 3, which means that the pressure difference, or the color difference, if we're color coding wires, across resistor 3 must be 12 volts, because 4 times 3 is 12. So now, let's code the wires using voltages. Highest pressure would be 24 volts, lowest pressure would be 0 volts. This is a 24 volt battery. We're told here in the table in the lower left that the pressure difference across resistor 3 is 12 volts from one side of resistor 3 to the other. This side of resistor 3 is 0 volts, therefore the color of this upper right portion of the circuit must be 12 volts, which means that the pressure difference across resistor 1 and across resistor 2 must be 12 volts. 24 on one side, 12 on the other. We can now figure out the current through resistors 1 and 2. 12 is equal to what times 8? 1.5 amps. Combination circuits have both series and parallel elements. The challenge in analyzing these is to use the appropriate rules, series or parallel, at the appropriate times for each section of the circuit. There is no prescribed order for analyzing circuits, which is why I call them circuit Sudoku problems. You and I can attempt the same problem and should come up with the same answers, regardless of the order in which we figure out the various quantities.